then we keep the soil black in that spot during the midsummer to try and stress these cecil colonies. Yeah. The question, I'll go back to show a bit more than take this one. The robot that we use is produced by Agro-Intelli. It's a Danish robot company. The robot today is manufactured in Denmark but sold throughout Europe. The robot is a tool carrier platform. So full commercially available. And what you can see here is the rotavator that's mounted on the robot is a standard 3-point hitched mounted implement. And that's the benefit of the robot. It enables us to use the whole range of standard implements. So tillage equipment, seeding equipment, weeding equipment is all commercially available, mountable on a tractor, but basically working with a robot, and then the robot's unique design enables us to have a very high accurate control. So as you can imagine, a implement mounted on the back of a tractor is affected by when the front wheels is steering. This robot is built kind of like embracing the implement, and that means it's always turning around the implement, giving us a much more accurate control and guidance of the implement, which is especially needed when we are driving and doing weeding in the narrow rows. Doing a tillage like this doesn't require the high accuracy as we do with the mechanical weeding, but that's where, if I had to do this job as a tractor driver, I would drive 2 to 3 kilometers. Typically, within a month, the robot would be driving somewhere between 120 to 140 kilometers with 2 to 3 kilometers power. That's boring. So that's really also where this is, as you can imagine, how many times it would go down such a field, just like this is a 10-hectare field. It's a lot of passes just to do that weeding. And during spring, we do that with 2 to 3 weeks of interval for each of these to keep the grass down. So I think this would be most likely at the 4th or 5th pass in late spring, because in the early, it's really a thick grass carpet that when we start the mulching, and then just before the berries start to mature, then we have this good crumble structure in the soil. But that's also where speed and power input to such a rotavator is very, very important, because you can easily destroy the soil structure if you over-intensify your tillage. So that's also good, because the robot, if you program it for one speed, one rotavator, then it's not getting stressed. It doesn't feel kind of like at the end of the day, I want to go home, and then it may speed up a bit. So it does the same work all the time, and that's a good thing. And even only doing 3 kilometers per hour, you can leave it running, and there's no pee break or dinner break or after-hour payments. So that's also a good thing with the robot. Yeah. So the question is on the robots, I would call it mobility. And even though this is in Denmark, I know there are robots driving in Switzerland, Austria, in France, in very much more hilly conditions. It's built to match so any land, and I think the EU regulation is that we can have up to 12% inclination in our EU subsidy program, and that's also where, so any field that follows the EU regulation and can be following the subsidy schemes for support, there the robot can also work. How you should see it is that there's a lot of weight saved from a tractor, which is basically going into driver comfort, which is not needed here. That's one way of making it lighter, so that even with a smaller engine, you can do more work. On the other hand, it's also the way it's designed by having the implement in the center. It's always putting the weight down to all four wheels instead of having something in the back of a tractor, which is basically lifting the front wheels. And therefore, you always see all this steel in the front of the tractor to basically counteract for this, I'll call it, um, design that's not really thought through, because the tractor is basically just a replacement of the horse, not thinking it through. And I think that's really what I like about the robot, because it puts the implement in the center, and makes the energy consumption much lower due to that. Uh, yeah. So the question on the, I would say, the soil strength or soil physics, I would say, I don't believe in mechanical loosening of the soil. I believe the biological loosening of soils is more sustainable or long lasting. I've seen too many studies on where you do mechanical loosening, but a mechanically loosened soil is more vulnerable for recompacting. So what we would rather do is try over time to use cover crops, root crops, like oilseed rape, mustache, and others, to help create a more resilient structure. So knowing we have areas where we might have old damages from soil compaction, the strategy is over time, simply by minimizing traffic, to have the soil kind of like um, finding a natural state instead. Yeah. Yeah. So the question is on the quality and the sales of the berries. Starting with the quality, that this is part of why we also entering into this project, because this is something that can be costly to map out, and this is really what we see as one of the main benefits of partnering in such a project, to get more insight to that. We know from our cereals that we have, in average, a much higher quality in our cereals for consume, with less toxic from fungi and others. Basically, because each strip, like the one to the left of the robot, could be seen as a corona bubble. So even though we might have a fungi infection 4 strips further to one side or another, it doesn't spread as easily. We don't have data today to support that in the berries, but this is one of our theses. We know that we have, for insects in our gooseberries, we have Copenhagen University as our partner. They have this season map that we can see we have less attacks of the Stickelsballau, I don't know, yeah, sawfly in the gooseberries. So there's less in the mixed crop part of the field compared to the monocrop part of the field. So we start seeing some of these effects, and we could also see that in a bit of the yield of the gooseberries this year. So we hope that with the yield monitoring here, that we will be able to see more of that in the coming years. The markets, until this year, we have sold both fresh for a few restaurants and bakeries, and then for industries. But this year, when we were out trying to employ pickers, because when we do for fresh, that's handpicked, but we weren't able to find staff to actually support the shop that would like to buy from us. So that has been a very minimum amount this year. So that means most of it goes to industry, where it goes into organic as juice and marmalade, as organic products. So still we get a decent payment for the product, and it's harvested with a tractor pulled harvester. That's a shaker harvester, and that one is actually driving in that black bed here, so that we can go in between the berry bushes and the cereals. Yeah. Yes. Not to a big extent today, no. So the question was if there are other weeds than that. I think that thistle is our main problem today. Hvad hedder skræpper? Højmøller, yeah. I think we've seen that for some of our neighbors that have organic fields for quite some years, but we haven't been challenged by it yet. So thistle is the main one. Good. Oh, yeah. There's a question now. See, there's a question if the robot can do pruning. Um, Basically, when we look at the robot is a tool carrier. So whatever tools that it fits to a 3-point linkage and needs minimum surveillance for continuous adjustments would be something we could implement today. We do the pruning of them with a what's it called, a finger scissor, hydraulic finger scissor on a small a mini loader where we go next to the varieties, but we have a lot in the varieties to keep them up straight. So in a field like this, we don't expect to do any pruning, at least for the coming years. Any thoughts into how and what vegetable would work in the system? Yes, and we've considered a lot. I think our main challenge is that we need to make sure that when we start, we need to build the business for it and have sufficient amount of it. And right now, I think in our area, the main challenge would be to have the labor to help us support it. It's a very good soil, not precisely where you see the picture from here. There's a lot of stone right here, but some of the other fields are very good for potatoes. So we see a high benefit for different kind of root crops like carrots, onions, and potatoes could be working quite well in the system, and it's something over time we would like to invest more in also increasing the value of the productivity in the zones in between the berry bushes. Yeah, I think that was the questions. 1 minute over time. Sorry, Line. Yeah. So without that, yeah, thank you.
Thank you very much.